Part of your lab this week is calculating molarity. And this can be a new concept, so I wanted to go over the calculations and do a couple of examples for you guys. The equation that you're going to be using looks like this. And you can rearrange it to calculate any one of these factors. So the molecular weight, which you can use your periodic table to determine, times the molarity, times the volume, which has to be in liters. So if you're given a volume in milliliters, you need to convert it to liters, equals the grams of solute. So in any instance, I would have to give you 3 of these, and you would determine the last one. You can always determine the molecular weight because I'll give you the periodic table. So then I'll have to give you 2 other pieces of information, and you'll have to solve for the 3rd one. There's a couple examples in your lab handout, and here we're going to go through 2 more additional ones. Okay, you want to make a 700 milliliter solution of 1.4 molar magnesium chloride. How many grams of magnesium chloride are needed? So let's put the equation on the board. We have molecular weight times molarity times the volume equals grams of solute. And in this case, we're trying to figure out the grams of solute, so we don't need to rearrange anything. The first thing we're going to do is figure out what the molecular weight of magnesium chloride is. Okay, so you can look at your periodic table, which is at the end of your lab. Magnesium on the periodic table is about 24 grams. Chlorine is about 35.5. We multiply that by 2, and so overall we have a molecular weight of 95. Okay, so we know our molecular weight is 95. Okay, we know what our molarity is, 1.4. And we know what our volume is, 700 milliliters. So instead of 700 milliliters, that's the same thing as 0.7 liters. So if we multiply that, 95 times 1.4 times 0.7, we get 93.1 grams. So you would have to dissolve 93.1 grams in 700 milliliters to get a 1.4 molar solution of magnesium chloride. Let's do another example. This one, again, we didn't have to rearrange anything because it was in the correct format to solve for grams. You dissolve 140 grams of potassium chloride into a total volume of 600 milliliters of water. What is the molarity of this solution? Okay, so we're going to be solving for something different, right? This time we are solving and trying to figure out what the molarity is. Okay, so this time we're solving for molarity. Again, we'll use our periodic table, figure out what the molecular weight of potassium chloride is. Potassium is 39, chloride, we remember from before, 35.5. So if we add those together, we get 74.5. Okay, so we can put that in. Times the molarity, times the volume, 600 milliliters. Again, we need to convert that to liters, so it'll be 0.6. And the grams of solute we're given is 140 grams. Okay, so I'm going to multiply 74.5 times 0.6, and I get 44.7 times the molarity equals 140. And then I'm going to divide both sides by 44.7 and get a final molarity of 3.13. And that would be the answer to the second one. Okay, so again, we had to rearrange this one a little bit, but as long as you're just solving for 1 out of the 4, it is very doable.